example 9. Okay, so the displacement at t equals 8, as t equals 8, is the area here, the area of a triangle, so 16 meters. The acceleration when t is greater than 6, that means the gradient of this line, because the gradient of a velocity time graph is the acceleration. So we just need the coordinates of 2 points on that line to work out the gradient, and we've got this point with coordinates 6, 4, and we have this point with coordinates 8, 0. So change in y over change in x, so minus 2 meters per second squared. The speed of p when t is equal to 15. Now velocity here is negative because you've got velocity on the vertical axis and you've got negative values here, so negative velocity, but speed is a scalar. So we could calculate the velocity here, but we need to give the final answer as a positive value. So I'm using v equals u plus at, a Suvat formula. What I'm looking for is the velocity here when t is equal to 15 seconds. We have the acceleration already. Now the time taken isn't 15. The acceleration here hasn't been going on at minus 2 meters per second squared for 15 seconds. It's only from here, so from here to here. So we're looking at this portion, or this stage of the journey, separately from this stage. So the time for this interval here, for which there is deceleration or negative acceleration, is 9 seconds. So the velocity is minus 14 meters per second, but we know that speed will be just 14, so the answer is 14 meters per second. Okay, for part 4, imagine a particle starts here, moves in one direction and is slowing down, comes to a stop and then starts moving in the other direction. It will pass this point where it started again and continue in this direction, but when it passes this point again on the way back, the displacement is 0, so it's back to where it started. Now in this question it says show that when t equals 12, p, our particle, is back at a, which means the displacement is 0. Now we already know the displacement here, we calculated that, so this should be the same area as this. So the displacement, when you add them together, a positive, a negative, they will cancel out, so you're back to where you started. So we know what the area here should be. So looking at the area of this triangle, it's going to be 16, so half the base, which is 12 minus 8, times the height of the triangle. So we're just looking at the scale here, so if that's 4 meters per second, that's going to be minus 4 and minus 8. So I know that this, on the triangle, this length here is 8. So let's see if that balances. So 12 minus 8 is 4 times that 8, 32 divided by 2, 16, yes. So if the area here is 16 and the area here is 16, when we look at displacement, anything above the horizontal axis is positive, anything below is negative, so if you add them together you get 0, a 0 displacement, so p is back at a.